Alright, here's the second video for section 2.2. This deals with reading intercepts off of a graph. What we just got finished doing was finding intercepts algebraically. Now, if you're given the graph, can you read them properly off of a graph? The main thing is writing them as ordered pairs and getting those zeros in the right spots. So, given a graph, write the x and the y intercepts as ordered pairs. So, what I need you to do in your notes is draw this graph exactly the way that I'm going to draw it, so we can accurately read these off. You can put about 5 tick marks on each axis. Alright, and put these dots exactly where I have them, and then we're just going to try to sketch this graph the way that I have it, and then we'll practice reading these intercepts off and writing them as ordered pairs. Alright, so let's just sort of make it come up through here, sort of curve through here, go down, and come back up this way. Again, as best you can sketch that in your notes, go ahead and do that. What we're focusing on are the intercepts, so make them cross at those tick marks. Alright, the answer we're going to put over here is going to be our x-intercepts. I'm going to list them as ordered pairs, and I'll put my y-intercept here. Alright. If you notice, I've got 3 different x-intercepts. So remember, with your x-intercept, the x value comes first. Let's start with this one over here. X is 1, 2, 3, negative. Negative 3, comma 0. Y is equal to 0. This ordered pair is, what, 2, comma 0. And this one over here, 1, 2, 3, 4, 5, 0. For your x-intercepts, you have to write them as ordered pairs. So pick those x's off properly, then your y's are equal to 0. Alright, for the y-intercept, there's only 1, and that's up at 1. So your y-intercept, x is 0. You don't go left or right, but you go straight up 1. Y is 1. Alright, that's not too bad. Remember, how to write those as ordered pairs is pretty important. Alright, let's talk about symmetry a bit. Symmetry is like a mirror image or a reflection. It can be reflected through the x-axis or the y-axis or the origin. So, we've got 3 different types of symmetry. To illustrate this, let's just look at one point, and then we'll expand it to a graph. Let's consider this point 2, 3. Again, just put about 4 tick marks on each axis, and I'll show you how we're going to reflect this. Alright, here's the point 1, 2, 1, 2, 3. That's the given point. 2, comma 3. Alright, if this is given. Alright, if I wanted to reflect this through the x-axis, here's my x-axis here. That means you would go straight through the x-axis and you go down the same amount, the same distance on the other side. That would be the point 2, comma, negative 3. This is x-axis symmetry. Alright, it was reflected straight through the x-axis, acting like a mirror. Alright, let's go back up to the given point. Let's do it with the y-axis. Y-axis symmetry means it gets reflected straight through the y-axis, goes the same distance on the other side, ends up here. That's the point negative 2, 3. And that is y-axis symmetry. Alright, and the origin is a point right here. So let's go back to the given point, reflect it straight through the origin, go the same distance on the other side, and you will end up way down here at -2, comma -3. Alright, that one's origin symmetry. Alright, that was just a quick illustration with just one point, but we will do this with whole functions. So that's sort of a quick little intro to symmetry. It's been about 5 minutes. Let me do some other symmetry stuff in the next video.